All right, let's solve this rational inequality. As soon as I see that greater than sign, I know I'm going to wind up drawing a number line, putting some points on the number line, and doing test values to see where the solutions are. So that's what's happening. That's the overview. One of the ways we find numbers that will go on the number line, those critical values, as they are called, is we will solve the related equation that we get by just replacing the greater than sign with the equal to sign. So we're going to solve this, and whatever we get, that's going to go on the number line. So let's do that. One way of solving these rational equations is to make the denominators be the same. So I see an x on the left, I can just put a denominator of x on the right. That's valid as long as I put an x up in the numerator as well. Once I have those like denominators, I can cancel them out and then make a new equation. So my new equation is x squared plus x minus 6 equals 0, because 0 times x is just 0. All right? Shireen, does that make sense so far, sweetheart? Okay. So I'm just going to solve this, and whatever I get, that's going to go on the number line, critical values. What do you think I'm going to do now, class? Factor. Okay, I'm going to try to factor. If it didn't factor, what would I do? Quadratic formula. Good job, Jorge. So x squared, I got x and x. I'm thinking it's either going to be 2 times 3 or 6 times 1. Which way is it going to be this time? 2 times 3. Yeah. All right, if I go 2 times 3, negative 2, positive 3, that'll do it. Any questions on that? All right, so I set these equal to 0 and solve. So I get x equals 2 and x equals negative 3. All right, so when it comes number line time, those are two things that are going to be on the number line. X equals 2 and x equals negative 3. That's what it was, right? Yeah. People that were here yesterday or watched the video I posted, what else goes on the number line other than the solutions to that equation? The excluded values. So that's the thing that's different from polynomials, which didn't have excluded values. Any excluded values will go on there. And I hear Shireen saying x cannot equal 0. That's the excluded value. Any questions so far? So these are the 3 things that are going to go on the number line. So we'll just do that, and then we'll do our test values and check them, and then that's how you do it. So here we go. So here comes the number line. Okay, so let's see. So over here will be negative 3, and then 0, and then 2. Students that were absent yesterday, I was emphasizing excluded values like the 0. Is this going to be an open circle or a closed circle? Excluded values are always open circles, all right? Because open circle means excluded, so there's got to be an open circle. What about the 2 and the negative 3? Sometimes those are open, sometimes those are closed. Which is it this time? This time it's going to be open. It depends on this symbol right here. When it's like this, just a greater than sign, that's when it's open. If it had been the greater than or equal to, that's when it would be closed. All right, to show that we're including the equal to values, because that's what these are. These are values where the function would be equal. So in this case, everything is going to be open circles. But sometimes these blue ones are closed. All right, so then we pick our test values. So for example, over here, I will do negative 4. In between here, I could do, for example, negative 2 or negative 1. In here, kind of obviously, I'm going to do 1. And out here, I'm going to do 3. All right, any questions right now? Is anybody feeling lost right now? Okay, especially kids that were absent yesterday. So I'm just going to check these test values. I'm going to use my TI-30XS multi-view. So I'm going to do this table feature, and I'm going to type in this left side of the equation. So x squared plus x minus 6 over x. Make sure you're in Ask X mode. Okay, so I'm checking -4 and -2. So I got -4 already. And then there's -2. Just delete that. So I have -3 over 2 and 2. So I have -3 over 2 and 2. And then I've got 1 and 3. So 1 and 3. So that's -4 and 2. So -4 and 2. Now in this case, we're asking ourselves if the function is greater than 0. It's not always 0 here, so don't just always do 0. But this time, greater than 0 is the question. Greater than 0, greater than 0, greater than 0, greater than 0, question mark. So, what's the yes-no pattern?
No, yes, no, yes.
No, yes, no, yes, in terms of if these statements are true. Is everybody comfortable with that? Okay, the yeses indicate solutions, so we will fill in anywhere we see a yes. All right, so we have from -3 to 0, that's really crooked, but whatever. And then we have another one from 2 to infinity. So that's why the interval notation was what it was. So that's why in interval notation the solution was -3 to 0, union 2 to infinity. Note my use of parentheses even on the constants instead of brackets. Why did I use parentheses instead of square brackets? They're not included. You see all the open circles? Anywhere you have an open circle, you're going to have parentheses to also show not included. So that's it.